So the last topic that we'll cover in this course is integration. What is integration? What is an integral? It's the antiderivative. So it's not the derivative, it's the other. But in terms of a curve, if you have a curve, let's say you have this curve. I want the integral of this curve between 0 and 2. What is the integral of this curve between 0 and 2? Conceptual. I don't want to buy. What is the integral of the curve between 0 and 2? Conceptual, no values. You don't know it, right? I didn't give you any values. So. Area under the curve. Area under the curve is the integral, right? Let's say this is x squared plus 1. Let's say this curve is x squared plus 1. I want the integral between 0 and 2. It's between 0 and 2 of x2 plus 1 dx, isn't it? Mm-hmm. How do we calculate this? How? Yeah, I know I have to integrate, but how do I integrate that? Yeah, so we basically want the primitive function, right? So that antiderivative will give us the primitive function. What's the primitive function for this? For this x squared plus 1, what's the derivative? Or what's the primitive function?
X cubed over 3 plus x.
It's x cubed over 3 plus x. Is it?
From 0 to 2.
Am I missing something? Plus a constant. It's not a plus c? It is, yeah. But let's say, yeah. So, good catch. Let's say I want the indefinite integral of x squared plus 1 dx. So indefinite means that I didn't define the thresholds, the boundaries, right? So indefinite integral is this. Now if I want a definite integral, then I have this function between 0 and 2, meaning that 2 will go to 2 to the power of 3 divided by 3 plus 2 plus c minus 0 to the power of 3 divided by 3 plus 0 plus c. Right? So that's the definite versus indefinite integral. But again, we are here to use MATLAB and to learn how to do this because this was an easy function, but we don't really always have easy functions. We want to use MATLAB to do the work for us. One thing that we need to do is that, see, I have x squared plus 1. X in this is a symbolic variable, right? What we have dealt with so far were vectors, numbers, scalars, matrices, right? So x was a matrix for us previously. X was a vector, or x was a scalar for us. Now what I'm dealing with is not a vector, it's not a matrix. It's a character x. It a symbol, right? So first thing that I have to do is I have to define that my x is a symbol. So SIMS x sims x will define x as a symbol. So x is not a value anymore. X is not a vector. It's not scalar. It's a symbol. Then to do the integral, I use int, integral, int. What it gives me is, again, not a value, it's a symbol. Is there any difference between that and this? Between what MATLAB gave me and what we derived? They look different, but are they different? They're not, right? So I have x. So what I have here is x times x squared plus 3. So what it becomes is x times x squared, x cubed, plus 3 times x divided by 3. X cubed divided by 3 plus 3 times x divided by 3, x. And the constant is not basically shown. So what I have here is the indefinite integral, right? Indefinite integral, I just define my variable x as symbolic. I use int, and I will get this is the analytical solution. This is the correct solution. That's exactly what it is. There is no approximation, there is nothing, right? So it's analytical solution to this integral. Does it make sense so far? But we also talked about definite integral from 0 to 2. If we want to do definite integral, we just define the boundaries. So x squared plus 1 from 0 to 2, it will give me 14 over 3. That's the value. 2 to the power of 3, 8. Divided by 3, I don't know, something. Plus 2. 2 times 3, 6. Plus 8, 14. Divided by 3, 14 divided by 3 is the answer. And I get a 14 divided by 3. Now, why do I get 14 divided by 3? Why don't I get, it's 4 point something, right? It's 4.67, something like that. Isn't it? Yeah, you get 14 over 3, but you don't get 4.6 or 4.7. That's what we usually got before, right? Have you ever seen 14 over 3 coming out of MATLAB? No. Look at the workspace. See, my x is a symbol. My answer is also a symbol. So that 14 over 3 is not a number. It's a symbol. That's why you don't get 4.67 or so. Now, if I want to translate that into a number, into a scalar, that I can multiply by and I can do all sorts of stuff, I need to transform it. I need to transform it from symbol to a value. How to do that? There is a function called double. Double basically changes anything that we give to it into a scalar, a double, a real number. So 14 over 3, as we expected, is 4.6667. And that double basically translated from symbolic value into an actual value. Does it make sense so far? So that's the analytical solution. Perfect. Sometimes we don't necessarily have any function. Or our function doesn't really have a primitive function. There are some functions that the primitive function is not defined for them. How do we deal with them? How do we deal with a set of data? So we don't basically have a function in the first place. So we can't really find the primitive function. We only have a set of data. How do we handle it? Instead of this, what I have is a bunch of values. And I want to integrate those bunch of values. How do I do that? Integral is, again, area under those values, isn't it? If I connect these dots with a line, can I calculate these trapezoidal areas? Right? I can use the trapezoidal rule to calculate the area, right? So basically, the area under the curve can be calculated with trapezoidal rule. Let me get rid of all I have so far, clear and CLC. I have a function. My function was x squared plus 1. That was my previous function. I define that as a function, as a handle, function handle, or handle function. Do you remember this, the handle? Do you remember inline function and then handle function? That's the handle function. Now what I want to do is evaluate some points on this curve and then imagine that I didn't have a curve in the first place. So my x was between 0 and 2 previously. Remember? I go from 0 with a step size of 0.5 to 2. That's my x values. And then my y values is f of those x values. So I have x equal to 0. Well, I have x equal to 0, x equal to 0.5, 1, 1.5, and let's say this is 2, and then it doesn't really go after that. So for each x value now, I have a y value, right? I have a bunch of x and y values now. Now I would forget that I have a function in the first place. Now I have a bunch of x and y values. Let me draw a better curve or better points. I have 0.5, 1, 1.5, and 2. At 0, I am at 1. At 0.5, I am at 1.25. At 1, I am at 2. At 1.5, I am at 3.25, and then I am somewhere here. I want to calculate these trapezoids. What's this area? I am at 1, I am at 1.25. What's the area for the first section?
It's 1 times 0.5 plus what? 0.75 times 0.5. Something. It's that triangle area.
It's a bunch of
10.5. Sorry, the area of the triangle plus the square.
2/3, 1/7, 1/6.
2/3?
And something like that. For trapezoid.
It's half of these two. So sum this plus this divided by 2 times height, isn't it? This plus this divided by 2 times height. So it's 1 plus 1.25 divided by 2 times 0.5. Make sense? Majority of the class is still in the Thanksgiving break. Looks like you had a lot of fun, so you don't want to get out of it. No? Not much fun? No? Why not?
I will see why I had fun.
Yeah, I put it up to the end. I got sick when I went home. Go back here.
Okay. All right. Back to this thing, and then I know that this is the time that you expect me to give you a function because you don't want to do all that like manually, don't you? Do you want to calculate each section's area? You don't want to do that. Of course, there is a function for that. Trap z, that's trapezoidal, right? Trap z of x comma y. Let me use CLC so everyone in the back can also see this. Trap z of x comma y. What was, so basically we are now estimating the area under the curve, but not now as an analytical solution. We have a numerical solution, right? We have a numerical solution. We approximated the analytical value. What was the analytical value?
4.67.
4.67. I estimated as 4.75. That 4.75 is because instead of having a curve here, instead of having a curve, I have a line. Does that make sense? So this is the error that I have because of not using a curve and using a line. The error is not terrible, but the error is there. How can I reduce that error?
Make your x value or your step size smaller.
With more x values, if I have more points, this curve basically looks like a line, right? If I have infinite number of points, that curve is basically the lines that connect the points. So as I increase the number of points, I will decrease the error. .468 now. Instead of 4.667, I have 4.68. If I further increase that step size, I will have closer and closer to the reality. So right now, so far, we have discussed the analytical solution. Analytical solution is perfect. That's it. There's no error. Then we have a numerical approximation of that analytical solution using trapezoidal rule. But how many points do I use? Do I use 10? Do I use 12? 200? 10,000? How many do I use? We don't know. But do you think we have a solution for that? You'd expect it, right? There is another function in MATLAB that doesn't give you the analytical solution, but it does give you an approximation, a numerical approximation that's very close to the analytical value. The built-in function, what it does, depending on what is the curvature of the function, it will adaptively put points. When you have more curvature, you need more points. When you have less curvature, you need less points, right? So the function that you can use is called integral. It needs a function, so that function handle goes in there. Integral of f between 0 and 2. That gives me the same answer, or very similar to what I have from the analytical solution, which was INT. Yes?
What's the difference between INT and integral?
INT is the analytical solution. Integral is the numerical solution. So basically, it uses that trapezoidal rule, but it will adaptively select where the points should be.
Okay.
Does that make sense?
Can you repeat that? INT versus
INT is analytical solution. So it will calculate the primitive function. It will evaluate the primitive function at the upper boundary, the lower boundary, and will give you the result. That's the analytical solution. Trapezoidal is the trapezoidal rule. That's a numerical solution. Integral is also a numerical solution, but in integral you don't have to define where your x and y values are. You just give your function that function handle, that x squared plus 1. That's your function handle. You will give that function handle to the function, to the built-in function integral. It will select where the x points should be. It will evaluate the y points given the function. So you have a set of x and y values, and it will calculate the area under those points. So basically, we have 3 ways to do this: analytical solution, trapezoidal. This integral is called adaptive quadrature. That's the numerical solution. It uses the method adaptive quadrature to specify where the x points are, and based on those x and y points, it will calculate the area under the curve. So with this, there is a short lecture right here that will summarize everything that we just talked about. And here is a summary of what you need for, let me make it bigger. For the analytical solution, you need the symbolic toolbox. So first thing first, you make it symbolic, names of x. And then you define your function f equal to x squared. Then you do integral of f if you want indefinite integral. If you want definite integral, you give it the boundaries. Then the other thing is, the definite integral that you get out of this is going to be a symbolic value. It's not going to be a number. If you want to make it a number, use the function double. Then we have the trapezoidal rule, for which if you have a function, you evaluate that function at some x values. So you define some x values, you evaluate your function, you get some y values, and then you use trapezoid of x on it. The other is adaptive quadrature. It's also a numerical approximation. You need a function for that, and the function should be defined as a function handle, not a symbolic function, not a symbolic x or y or anything, right? This is now a function handle. And then you will take integral of f, that function handle, between upper bound and lower. Couple of questions. If I ask you for definite integral, what can you use?
The last option, number 3.
Definite. For definite, I can use either one. For definite integral, I can use either one.
The number 3 will be faster.
Would be faster.
You create the function and then.
Yeah. If I want an indefinite integral, indefinite, int only. Indefinite is basically the primitive function. Indefinite is the primitive function. You cannot have indefinite function with trapz or integral. The only thing is int.
So definite can use either of any three of them?
For definite, you can use either. For indefinite, you can only use int. If I give you a bunch of points, and if I want the integral, what is the method that we use? Trapezoid. Trapz, if I give you a bunch of points, if you don't have a function in the first place, the only thing that you can use is trapz. Unless you feed a function to those data, and then use that function with other methods. Does it make sense? So it's all summarized here. That's all you need to know. With that, we can move to homeworks. Let's work on a few things together. Let's start working on question 4. Let me give you a couple of minutes. I will stop recording, and then as I resume, I'll resume the recording as well. Hopefully I have your curiosity already, and let's get this running. So the area is basically this, right? All of it. It's going from -1 to 1, isn't it? So that's half of the issue. Then my function is x squared plus y squared equal to 1. If I want to evaluate this, I have a double integral. That's a trouble by itself. I don't want to go through the double integral. Let's simplify this. Y squared is equal to 1 minus x squared. Right? Is that right? Then y is square root of 1 minus x squared. Is that right? Is this right?
Yes.
Square root isn't square root positive? Always? Plus and minus. Because if I don't have the minus, I only have the upper side. I don't have the lower side. Now, the other thing that I want to ask you, well, let's do it together. Let me not ask you at the moment. CLC, clear, everything is gone. My F is, can I do plus minus in MATLAB? square root of 1 minus x dot squared. Is that all right?
You need to dot it.
I need a dot. Reason for that is when you're dealing with the, especially when you're dealing with the numerical approximation like the trap Z, you have a bunch of x values that you want to evaluate, right? So x squared wouldn't work if there's not a dot, because for each x value I need a y value. Make sense? Yes, Jen.
So are you saying using the
I'm going to use integral for this. I can also use INT, and I can do both actually. I'll do both. I can also use trap Z, but that, that's just harder than integral, so I don't want to do that. So that's my plus sign. That's the upper sign. Integral of f between -1 and 1 is 1.57. So that's 1.57. Everything all right, Francisco?
Yeah.
So the upper side is 157. Let's do the lower side. I define my f. Now I have to define, so I define the upper side, I have to define the lower side as well. And then integral well, now I have negative 1.5. If I add the integral from the upper side to the integral from the lower side, what will I get? Zero. What's the issue?
You get absolute value.
We need absolute value. Integral of the area above 0 is positive. Integral of the area below 0 is negative. If you add them together, especially in this case that you have a symmetrical problem at hand, they will cancel out. If you're in the area, you don't care about the direction. That positive negative is the direction, right? You care about the absolute value, don't you? So basically, I will have to do this. Integral of this, so let me CLC, absolute value of integral of f between -1 and 1. This was my negative side. And then absolute value of integral of negative f from -1 to 1. Doesn't work like that, so I have to define my f again. So f, let me define f as the upper side, and let me define g as the lower side. And then I can calculate the absolute integral or absolute value of the integral of the upper function, the lower function, add them together, that's my area. Pi is what in terms of value? 3.14. Yes.
Is there a reason why we wouldn't just add it into the function above and just go like, so we have the original function and then go add absolute and the negative square root? So as that on here, it works.
It works, that's it.
Oh.
Is there a reason why we wouldn't do that?
So what you're doing is you're doubling the upper function. That's it. Because that absolute value of negative is basically 2 times that. That's the lower side to the upper side. Are you good with this? Question 4? Any questions? No?
So the question is asking
For the area of the circle. We just calculated the area of the circle. So that was using numerical approximation. I can also do analytical. That would be sims of x and f equal to sqrt of 1 minus x squared. And then that would be int of f between -1 and 1. It's pi over 2.
Not a number.
Yeah, that's a pi. 2 times that integral is a pi. If I use the analytical solution. Because it's symmetrical, I just multiply the upper side by 2. I can do the lower side as well. Yes?
So the first time that you do INT, that however you get pi over 2, so that's, isn't that technically not a number? It's a symbol. So then you
It's a symbol.
So wouldn't you do double pi of 2? Or are you doing like 2 times the thing?
Well, that is because I have an upper side and I have a lower side. I want to add them together. So that's 2 times that integral. Does it make sense? Perfect. Let's work on question 5. You also have the same situation. You have a positive side, you have a negative side. So be careful when you're doing that, right? An artist is hired to paint the area defined by, well, let's solve this actually. Let's solve this quickly. I give you a couple of minutes. All right, let's do it together. Clear CLC again. My function is @x dot times x minus 1 times x minus 2. That's my function, right?
You can put x squared minus 3x plus 3.
You can.
Yes.
Yeah, you can do that. You can do that. But in MATLAB, let MATLAB do that for you.
Oh,
Because-
you want to not.
Yeah, because you're going to make mistake. MATLAB is not going to make mistake.
Oh, okay.
Yes, Jen.
Can you just use INT? Like, I don't know why, can't you just use symbol x and then f equals whatever the function is?
You can. Yeah, as long as you have a function, you can do either.
Okay.
The reason that this is better is that I can plot this. I can plot this now. X is changing between 0 and 2, right? So I can do linspace of 0 and 2, plot x comma f of x. I can plot this and see that part of it is positive, part of it is negative. If I use symbolic, then I cannot plot symbolic function. If I do integral of f between 0 and 2, that's $0. Because per square meter, the painter is going to get $50. $50 per square meter. And then your value is basically 8.6 times 10 to the power of 19. So the poor painter painted something, but you're going to pay him or her 0 because you just made a mistake in calculating the integral. But if I go from 0 to 1, that's 0.25. If I go from 1 to 2, that's negative 0.25. That's why I get 0, because they cancel out. So what I can do is I can do 2 times integral between 0 and 1 because they're symmetrical, and then $50 per square meter. That's how much you pay, $25. Yeah. Does it make sense to everyone? Yes. Let me stop this and then I'll come. As we move on, let's go to question. Let's go to question 10. Yeah, let's do question 10, and then I'll give you a couple of minutes, and then we can do it together. All right, let me ask you this. What am I asking in this question in the first place? I want the integral between t1 and t2 of q times c dt. And c is a function of time. For different times, I have different c values. And q is 30. So this integral, basically q is constant, isn't it? Q can come out. So that's q times integral of c dt between t1 and t2. And all that I observed are these values. So what does integral of c dt mean? What's the meaning of integral of c dt? Integral of c dt, if t is x value and c is your y,
The answer will be Q.
the answer will be no. The answer will be the area between c and t, right? The area between curve c and axis t. That's the same thing as x and y. So x is x-axis or horizontal, y is vertical. In this case, we have t as horizontal, c as vertical. And we have a bunch of points. So when we have a bunch of points, the only thing that you can use, the only method that you can use is trapezoid. So you have your t values, you have your c values, trapezoidal. Is it c comma t or is it t comma c?
It's the T comma C.
It's t comma c, because t is your x values, c is your y value. So trap z t comma c.
Doesn't have to be T comma QC.
Yeah, it's either t comma qc or q times trap z of t comma c. Either. Does it make sense? No? Yes. Kind of.
I think I got it. Yeah, I got this.
So I'll copy these values. So one way to do this is trap z of t comma q was what? 30? 30 times c. That's one way. Or 30 times trap z of t comma c. They're the same. Should be the same. That integral qc dt, q was constant, right? So you can write it as q times integral of c dt. Upper one is trap z t comma qc. Lower one is q times trap z t comma c. Does it make sense, Nicole? Because this q is constant, I can take it outside the integral. Constant times value. Well, no, it's not plus q. It's q times c. So I can take q outside and do it q times integral. Does it make sense?
We can define q equals story and then we can put them. Yeah.
You can do that. Does it make sense? Everyone's clear? What if you want to do question number 11? How do we do this? What is the value of this integral f of x dx between 0 and 1?
The integral
It's integral of f dx between 0 and 1. And I have a bunch of values for x and f. What is the method that I can use for this? Still trap z, right? We don't have a function. We only have a bunch of points. The only thing that I can do is trap z. It asks between 0 and 1. As you can see, x is changing between 0 and 1. If I give you a bunch of points and I ask you what's the integral between 0 and 1, between 0 and 0.5, which points do you use?
3 points.
0, 0.2, 0.5. That's if I ask you what's the value of that integral between 0 and 0.5. If I ask you between 0 and 0.5, x only goes to 0.5. It doesn't go above. Does it make sense? I asked you between 0 and 1, so it goes from the first value to the last value. Trap z. Define x, define f, and then trap z of x comma f. It's not f comma x, x comma f. Because that's dx.
Will it not work if you put f of x in there?
It is gonna work, but the values might be different. The integral value might be different. Remember that? Remember this plus this times this? If you change the other way around, it's going to be this plus this times this.
I was actually asking if you put the word f parentheses x.
Oh, f parentheses x is not going to work.
It's not gonna work.
Because when you do f parentheses x, it means that f is a function and you want to give it some input. F is not a function in here. I mean, in mathematics, it is a function. But what we have is a bunch of points. And that's the vector. That's it. So it's not, you cannot have a vector of f of x.
Okay.
That's f equal to that definition of that vector, or whatever it is. Does it make sense? Awesome. So I'm going to stop here.